All right, last 5 for patterns and sequences. Here we go, number 11. In the geometric sequence below, the first term is 2. If it can be determined, what is the 7th term? Well, we know it can be determined, so we're going to rule out E, right? And I've given, it goes positive, negative, positive, negative, positive, and then the 6th term would be negative, and then the 7th term, which is what they're looking for, would be positive, right? So I can rule out A and B because I know it's got to be positive. Now, if I think about it, we're multiplying by -3 each time. So 162 times -3 is already at -486. So it has to be D because I know I'm going to have to go bigger. Okay. All right, number 12. Let Q, R, S, and T be distinct positive integers. What is the 4th term of the geometric sequence below? Okay, so all you're doing is looking for the pattern. If I notice RS stays the same all the way through, right? Nothing changes with RS. But then I start adding a T every time and a Q every time. So if I add another Q, that would be Q4. RS stays the same, and I'm at T squared. That would be T to the 3rd. So if I look, my answer is G. That one's not too bad. They like to throw questions like that at you sometimes without any numbers. All right, what is the 4th term of the geometric sequence? Okay, so I'm going positive, negative, positive. I know my 4th term is going to be negative, so I can rule out D and E, right? All right, so if I look, I'm dividing by 3 each time, right? -3, actually. And so if I look at that, 6 divided by -3 is -2. So that's my answer. Okay. All right, moving on. 14 was a weird question, but I promise you it's not that bad. All right, so it gives you 1/13 in decimal form, and it says it repeats. If you notice, it does 1, 2, 3, 4, 5, 6 numbers, and then it repeats 1, 2, 3, 4, 5, 6. Okay, so 16 times 6 will give me 96. So it'll go through there 96 times, right? Okay. I'm left with 4 digits. So on the 96th time, it's going to be on a 3, right? And then I'd say 97th, 98th, 99th, 100th. So 9 would be my answer. Okay. All right. And then the last one, it's talking about particular bacteria is directly proportional to its population the day before. If there are 180 bacteria on day 1, there'd be 240 bacteria on day 2. All right, so automatically I should know that I can make a geometric sequence with this. I'm going to roll A, B, and E. So if I think about this, all I have to do is take 240 divided by 180. And if I put that in the calculator and reduce it, I get 4/3. Okay, 240 divided by 180. Remember, take your second term divided by your first term and reduce it, and that's 4/3. So my answer is D.